Hello everyone, this is Mr. McMillan, and this is the instructional video on the converse of the Pythagorean theorem and its applications. This is also known as the Pythagorean inequality theorem. That's what you'll see it on when you do IXL, is I believe it calls it Pythagorean inequalities. So it means exactly the same thing, okay? And the reason it's called the Pythagorean inequality theorem is it's not just going to be equal to anymore. We're going to be using the Pythagorean theorem to determine whether something's acute or obtuse as well, okay? So up here, this is just a summary of the Pythagorean theorem that we've been working with. But we can also use the related postulates to classify triangles algebraically. So that is, when given side lengths, we can determine whether a triangle is an acute triangle, a right triangle, or an obtuse triangle. So let's see how we would go about that. And we're going to go over several examples in this video. And you don't have to watch the whole thing. If you have the examples and you understand it, then you know, good, go ahead and do the IXL and you'll be good to go, okay? Otherwise, you know, make sure you stick around and watch the video and try to understand what's going on with it. So in triangle ABC with the longest side C, so longest side is always going to be C. Here's your inequalities. If A squared plus B squared, it's not going to be equal to this time. Instead, A squared plus B squared is going to be greater than C squared. So in other words, C squared is smaller than the sum of A squared plus B squared. Okay, so C squared is small. It's the smallest thing. Then that means that triangle ABC is acute. Okay. So if C squared is real small, triangle ABC is acute. Okay. And the reason for this is as C squared gets smaller and smaller and smaller, basically what it does is it scrunches up the angles, okay? It makes them smaller and smaller and smaller as well. So as these sides get closer in length together, it makes it to where it will always go to an acute triangle. Think of an equilateral triangle, right, that has everything equal. It's always acute, and that's because it can't get away from this inequality, all right? Now, the one we've been working with is the Pythagorean theorem itself. If A squared plus B squared equals C squared, then that means that triangle ABC is a right triangle. Okay? And remember that C is your hypotenuse, A is your short leg, I tend to call it, but it can just be leg, and then B is your long leg. Okay? And then finally, if A squared plus B squared is instead less than C squared, so in other words, C squared is larger than the sum of A squared plus B squared, so C squared's really big, that means that C is going to stretch out the triangle and make one of the angles an obtuse angle, which makes it an obtuse triangle. Okay, so the long side does affect it. If it's closer in length to the other ones, then it's going to be acute, but if it's far longer in length than the other ones, then it's going to be obtuse. Okay. Sorry about that. I thought the dog was just falling off the couch or something. So let's look at some examples to see how we can identify the acute, obtuse, and right triangles using that. We've already done the right, but now we're going to add acute and obtuse onto this. So this is examples from page 5. We only went over a few in class due to time constraints, but we're going to go over all of these. And again, you can, you know, as soon as you understand it, you know, leave the video and go to the IXL problems to do those. Okay. So in each of these problems, all 15 of these problems, we want to state if the three side lengths form an acute, obtuse, or right triangle. So the key thing here is we're still going to find out what A, B, and C are. We're still going to be doing A squared plus B squared and C squared. But the only thing that's different is we're going to compare them, their values for what they are, to see if they're acute, obtuse, or right. So let's look at number one. Number one, we have 9, 12, and 18. Remember that C is the longest side. Okay, C is the longest side. So in here we have 9, 12, and 18, which would make 18C because it's the longest side. A tends to be our shorter of the two remaining sides, so I'm going to call that A equal to 9 and 12 as B. Now the reason A and B, I do it for consistency's sake, but the reason why you could make either one A or B is because they're on the same side anyway. You know, switching them isn't going to make a difference. So we have A squared plus B squared, and C squared. And we're going to do these kind of separately from one another. We're going to do A squared plus B squared first, and then C squared. So A squared plus B squared is the same as 9 squared plus 12 squared. So 9 squared is 81. 12 squared is 144. And then if we take 81 plus 144, we end up with 225. 225. Now let's look at C squared. Okay, so we know what A squared plus B squared is. Now C squared is 18 squared. And when we do that, 18 squared gives us, I believe, 324. Okay, and let me make sure that before I do that. Yes, 324. Okay. So 18 squared, 324. Now you look here. This is C squared. We're going to be focusing on C squared. Now, is C squared smaller, equal to, or larger than 225? And the answer is that 324 is much larger than 225. Okay, so 324 is greater than 225. C squared is large. So that means that we're dealing with an obtuse triangle. And if you look at the inequality that I just put down there, if A squared plus B squared is less than C squared has to be larger. That means it's obtuse. Okay. Now let's look at number two. We've got 12, 16, and 20. Again, we're still going to be finding out what our longest side is first. And our longest side in this case is 20. So C is 20. Then A is our shortest of the remaining two sides, which is 12, and B is 16. So we're going to do A squared plus B squared and C squared for our calculations. A squared is 12 squared plus B squared being 16 squared. 12 squared is 144. 16 squared is 256. And if you take 144 and add 256, you end up with 400. All right. C squared, 20. 20 squared. And if you type 20 squared in, I'm going to do it just to show you, you'll get 400. So now we look at C squared. Is C squared smaller, equal to, or larger than 400? Well, you should be able to see that these two are equal. So if they are equal, that means that means we are dealing with a right triangle. And again, I do apologize for the coughing. I'm under the weather right now. All right, number 3. We have 9, 13, and 15. 9, 13, and 15. So again, we're going to be looking for our longest side, and our longest side would be 15, so that's going to be our C value. A would be 9, and B would be 13. So we're going to do A squared plus B squared and C squared. A squared, 9 squared plus 13 squared. 9 squared is 81. 13 squared is 169. And 81 plus 169 gives us 250. Okay. Now if we look here, we have C squared. C squared should be 15 squared. And if you do 15 squared, you'll end up with 225. So here we're looking at C squared. Is C squared smaller than, equal to, or greater than 250? Well, 225 is less than 250, so C squared is smaller. And since C squared is small, we know that this triangle is an acute triangle. Okay, so basically, again, you're looking for whether C squared is big, small, or equal to. Okay, the smallest type of triangle is an acute triangle because it's got the smallest angles. The equal to, right, and then the obtuse is your largest triangle. It's your more spread out triangle. Okay, so if you want to, you can try some of these with some of the class, or I believe with fourth block, I told them to do numbers 4 through 7, and then we check those. So do those and see, come back to the video, see if you got them right. Okay, so you're going to have one of the 3 answers, whether they're obtuse, right, or acute. So make sure that you look at those. Okay, so let's, if you're back from the video, let's, or back from working these out, let's look at number 4. We've got 9, 12, and 15. Our largest side is C, which is 15. A is 9, and B is 12. So A squared plus B squared. A squared plus B squared would end up with 9 squared plus 12 squared, which is 81 plus 144, which is 225. Then C squared would be 15 squared. And as we found out in number 3, 15 squared is 225. Is C squared smaller than, equal to, or larger than? And if we look here, 225 is the same as 225. So C squared is equal, which means that you have a right triangle. All right, number 5. We've got 5, 12, and 14. Our largest side is 14. So that's our C value. A would be 5, and B would be 12. So we're going to do A squared plus B squared equals, or not equals, but, and then compare it to C squared. So A squared plus B squared would be 5 squared plus 12 squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is equal to 169. Then we do this C squared. C squared would be 14 squared. And 14 squared gives us 200, or sorry, not 200, that gives us 196. Sorry about that. So now let's compare 196 and 169. C squared is 116 or 196. Is 196 smaller than, equal to, or larger than 169? And the answer is that 196 is greater than 169. So C squared is large. So that means that we are dealing with an obtuse triangle. Number 6, we have 45, 27, and 31. Our longest side would be 45, so 45 is our C value. 27 is our shortest side, so it's A, and 31 is B. Then we do A squared plus B squared and C squared. A squared plus B squared would be 27 squared plus 31 squared. 27 squared is 729 plus 31 squared. 31 squared is 961. 729 plus 961 is 1690. Now let's do C squared. C squared is 45 squared. 45 squared is 2025. So 1690 and 2025. 2025, if you look here, is it smaller than, equal to, or larger than 1690? And you should see that 2025 is larger than 1690, which means that we have an obtuse triangle. Okay. And number 7. Number 7, we have 35, 12, and 37. Our longest side would be C. So C would be 37, A would be 12, and B would be 35. And now we have A squared plus B squared and C squared. A squared plus B squared would be 12 squared plus 35 squared. 12 squared is 144. 35 squared is 1225. 144 plus 1225 is 1369. Then we do C squared, so we do 37 squared. And if we do 37 times 37, we get 1369. 1369 is equal to 1369. So C squared is equal, which means we have a right triangle. Okay. So those were numbers 1 through 7. Now, if you are still having issues with this, I'm going to be going over a few different ones. They've got some radicals in them and decimals, but the same concepts apply. If you're good with this, go ahead and work on the IXL Q.2. That was assigned a minimum score of 80. You could probably easily get it up to 90, 100. It doesn't change much. It just changes whether you're using decimals or radicals or whatever else. Okay. If you are having difficulties still, make sure that you stick around in this video for numbers 8 through 15. Okay. All right, so let's look at numbers 8 through 15. So number 8, we have 11.2, 13, and 11.2. Our largest side is 13, so that's our C. And since 11.2, they're both the same, it doesn't matter which one we label as A and which one we label as B. Okay. So we're still going to be doing A squared plus B squared equals, or not equals, but and C squared. A squared plus B squared will be 11.2 squared plus 11.2 squared. And if we type that in. We get 125.44 plus 125.44, which is 250.88. Then we do 13 squared for c squared, and 13 squared is 169. 169 is much smaller than 250.88, so c squared is small, which means this would be an acute triangle. Number 9. Number 9, we have the square root of 35, 16, and the square root of 293. And if we look to see which one's larger, it should be square root of 293, and it is. So square root of 293 is our c value, 16 is our b value, and root 35 is our a value. So we do a squared plus b squared and c squared. A squared is root 35 squared, plus b squared is 16 squared. Root 35, remember the radical cancels out the 35, or the radical cancels out with the squared, so it just leaves 35 behind. And then 16 squared is 256, plus 35 is 291. Then c squared would be the square root of 293 squared. The squared cancels out, and all that leaves behind is the 293. Is 293 less than, equal to, or greater than 291? C squared is greater than 291. So c squared is large. So that means that we are dealing with an obtuse triangle. All right, let's look at number 10. Number 10. Number 10, we've got the square root of 205, 16, and 7. So we're going to do the square root of 205, which is 14.3. So that means that our c value is 16 since our the largest. A would be 7, and b would be root 205. So we do a squared plus b squared and c squared. A squared plus b squared would be 7 squared plus root 205 squared. 7 squared is 49, and 205, or square root of 205 squared is, as you can see, 205. All right, then 49 plus 205 would give you 254. C squared would be 16 squared, and as we found out in the last one, 16 squared is 256. Is 256 less than, equal to, or greater than 254? 256 is larger than 254. So that means c squared is large, which means we are dealing with an obtuse triangle. All right. Now let's look at number 11. Number 11, we have 4, 2, and 2 root 5. So if we look at root 5 times 2, that's our decimal. So that means our c value is 2 root 5. Our a value is 2, and b is 4. So we do a squared plus b squared and c squared. A squared is 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. 4 plus 16 is 20. Now we're going to look at c squared. C squared is 2 root 5 squared. Make sure if you put this into Desmos, make sure you put that parentheses around it and square it. And I've already got what 2 root 5 is here, so I'm just going to press the square button, and that means that 2 root 5 squared is 20. 20 and 20 are the same here, so c squared is equal. So we are dealing with a right triangle. Number 12. Number 12, we have 11, root 317, and 16. So we have to see what the decimal is for root 317. And since it's 17.8, that would make it the largest. So C is root 317. Our A value would be 11, and B would be 16. So A squared plus B squared. A squared plus B squared would be 11 squared plus 16 squared. 11 squared is 121. 16 squared is 256. And then 121 plus 256 is 377. Then we have C squared here. C squared would be the square root of 317 squared. The square root and the square root, or the square root and the square would cancel, and that would leave you with 317. And now look at 317 and 377. Is 317 smaller than, equal to, or greater than 377? And 317, c squared, is small, which means that you are dealing with an acute triangle. All right, now let's look at number 13. Again, if you're good with this, you can go ahead and move on to the IXL. Still need some, or you just want to watch the whole video, then by all means. So number 13, we've got root 37, root 88, and 11. So we're going to take root 37 and root 88. And if we look here, we see that root 88 is 9.38, which would mean 11 would be our C value. Our A value would be root 37, and root 88 would be our B value. Then we do A squared plus B squared, and we do C squared. A squared plus B squared, this would be root 37 squared plus root 88 squared. And for both of these, the square root cancels out the radical, so it just falls away, and that just leaves us with 37 plus 88. And 37 plus 88 is 125. Then we do C squared. C squared would be 11 squared, which is 121. And if we look at 125 and 121, 121 is less than 125. So C squared is small. So that means we are dealing with an acute triangle. All right, number 14, we have 19.5 inches, 40 inches, and 44.5 inches. So our C value is 44.5. Our A value is 19.5, and B is 40. So then we take A squared plus B squared and C squared. A squared plus B squared would be 19.5 squared plus 40 squared. 19.5 times 19.5 is 380.25, and 40 squared should be 1600. Adding those together, we get 1980.25. And then C squared would be 44.5 squared, which is 1980.25. These two are equal, So C squared is equal. That means that it is right. And finally, number 15. Number 15, we have root 209. 7 and 15. 15 is our largest. So that'll be our C value. Root 209 would be our B value, and 7 would be our A value. We do A squared plus B squared and C squared. So 7 squared plus 15, or sorry, not that. 7 squared plus root 209 squared. 7 squared is 49. Root 209 squared would be 209 because the radical would cancel. Then 49 plus 209 is 258. Then we take C squared. C squared is 15 squared, which is 225. 225 is less than 258. So C squared is small, which means we have an acute triangle. Okay. All right, so I hope this video helps, guys. If you did stick around for the whole thing, just to get a bit more practice, then that's a good thing, because that means you are trying to get your head around this concept here. If you do have any more questions about it, please let me know. We are going to be doing some IXL, or we're doing the IXL Q.2 with this, up to a minimum score of 80. Or Q.3, whichever one. Q.3 maybe. Either way, we'll be doing all the Qs within this next week and a day or so. Okay, so I'll be back next time with the next instructional video, which will basically just be a set of example problems before I have you guys do some IXL. Okay, thanks guys, and I will see you in the next video.